Section 10.9. We're going to graph nonlinear inequalities. And, again, this is something, I think the nonlinear stuff might sound a bit more intimidating. Systems of inequalities is another expression for some of these things. Now, when you're graphing an inequality, the first thing you do is you're going to graph the corresponding equation. And what I want you to keep in mind is this. If you have less than or equal to or greater than or equal to, use a solid line to draw your graph. If you have a less than or greater than, you're going to use a dashed line to draw your graph. So that's what we're going to start out with, is drawing the corresponding equation. After you draw the corresponding equation, on one side of a line or the other is going to be a set of points that satisfy your inequality. You're going to want to shade that side. If you have more than one inequality at a time, then you're going to need to see where those two shaded regions overlap. So we'll start with problem number 32. So we got two equations in problem number 32, two inequalities I should say. 3x minus y is less than 21, and let's see, the other one is 2x plus 3y is greater than 12. Now I've already drawn these two lines for you. I hope that you can graph the corresponding equations. The corresponding equations, of course, would be 2x plus 3y equals 12 and 3x minus y equals 21. So you're going to start by graphing each of those. And let me kind of look at those in terms of some colored graphs. So here and here. If you want to borrow some rulers, I've got plenty up here. Take advantage of them. But because this is a greater than, I'm going to use a dashed line to draw this. Now my software didn't allow me to do dashed lines, so we're kind of doing this one by hand. Then obviously this is the other line. Y-intercept of negative 21 is lower than I wanted to draw this graph, so we'll just draw it like this. I'm not actually going to see the y-intercept. But keep in mind these are inequalities. So on one side of the line or the other are going to be points that satisfy the inequality. And the question is, what side satisfies the inequality? Well, the good news is that you don't have to do too much to figure that out. All we're going to do is pick a point and test it. And let's see what happens. For instance, my favorite test point is 0, 0. As long as your lines don't cross through 0, 0, then you can use that as a test point. If I put in 0, 0, is that going to be true? In other words, if I did, say, 0, 0 as my test point, 2 times 0 plus 3 times 0, is that greater than 12? Is that true or false? False. So this point, along with every other point on the underside of this line, don't satisfy the inequality. The points on the above side will satisfy the inequality. And what I'll do is I'm just going to draw a little arrow here for right now. Some arrows up above telling me that this is the side that satisfies the inequality. We're going to repeat that process for this part right here. Let's decide if 0, 0 satisfies the inequality here or not. So I'll put in a 0, 0. Again, we'll test that point, 0, 0. 3 times 0 minus 0, is that less than 21? Is that true or false? True. So do I want to shade the side kind of below to the right or above to the left of this line? Well, this made it true, so I kind of want to shade up here. Now the question is, where do these shaded regions overlap? Can you see where those two things cross each other? In fact, try and shade that part of it while I graph it up here on Desmos. So my two inequalities are 2x plus 3y is greater than 12. And the second one was 3x minus y is less than 21. All right, so where'd they overlap? Well, right here in this wedge here. So for your final solution, you can do one of a couple things. You can do what Desmos did and then graph both of them. And then what I'd like you to do is just write solution over the region where they intersect. Or instead of like shading everything and turning this into a big coloring exercise like you had in like grade school, you can just shade in the solution. So the solution is this part right there. That's where those two shaded regions overlap. So this is your solution. What's going to be different about this as opposed to your Math 1150 class is that we're no longer just going to restrict ourselves to just the graphs of lines. We can work with the graphs of other things, like problem number 22 does. So before I get to problem number 22, are we okay with problem number 32? Let's back up a step and look at problem number 22. We've got this equation, or excuse me, this inequality, x squared plus y minus 2 squared equals, or excuse me, is it greater than or equal to, or, yeah, less than or equal to 4. Less than or equal to 4. Now something like this would begin by graphing x squared plus y minus 2 squared equals 4. Does anyone recognize this equation? All right, let's figure out a few things. Obviously, it's a circle.
We have a radius of 2.
Good, a radius of 2. Now, the radius is going to be the square root of this number. So r equals the square root of 4, which is 2.
The center is at
0 and 2. Yes. So as far as the coordinates of the center is concerned, you want to make this term equal to 0 and this term equal to 0. The first term is equal to 0 when x is 0. The second term is equal to 0 when when y equals 2. Yeah, it looks like I rescaled this wrong. It's not graphed correctly. Yeah. It is, it's just scaled wrong. This should be a 4. And that make that a 2. There we go. All right, so I had the wrong scale there. Sorry, don't shoot me. So a circle of radius 2, centered at 0, 2. Now we need to decide where we're going to shade. Are we going to shade on the inside or are we going to shade on the outside? So for that I need a test point. Can I use 0, 0 as my test point? No, because the graph goes through 0, 0. So what am I going to do?
Test it at 0, 5.
Test it at 0, 5? 0, 2 would be a good one. 0, 2 is right in the center. So we'll test point at 0, 2. So 0 squared plus 2 minus 2 squared, is that less or equal to 4? True or false? That's true. Where's that going to tell me I have to shade then? Inside. Yeah, inside the circle. Because it's inside that makes this true. So let's shade inside. I like this. It's my evil eye rendition here. All right. Should I draw a big heavy eyebrow too? All right, so you need to shade inside here is the bottom line on problem number 22. Was I right to use a solid line on this one? Yes, you had a less than or equal to as part of your inequality. Okay, let's try another one. Let's skip down to the example right below this. And this is a little extra practice with circles. So here, the corresponding equation is going to be 2x squared plus, or excuse me, 2x plus y squared equals 1. And the graph of that's just going to be a parabola. That part's already graphed for us. So that one's already done. But how about the next one where I've got, x squared plus y squared equals 9. Now Lucas helped us out with the last one. Someone else for this one. I haven't heard from him in a while. M, thanks for volunteering. What's the center of this circle? Well, what would make the x squared term equal to 0? 0. What would make the y squared term equal to 0? What's the radius? 3. Now, you might notice that the graph of the circle here is missing, right? So here's what I would suggest. Start out the center, and let's draw the points of the compass. North, south, east, and west. So here, 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 and here. Now, what kind of a line should I use to draw my circle? Dashed. Because this is a less than. Yeah. Somebody's like, I anticipate screwing that up on the exam. Which isn't exactly what you said, but I won't repeat that for the video. All right, so there.
You don't have a project.
I don't.
Got slide calculator.
There we go. Okay, so I've got my two graphs now. The next part is to decide where I want to shade. Am I shading inside, outside, and where do these shaded regions overlap? So I'm going to give you a moment to try and figure that out. Can I use 0, 0 as a test point for both of these? Yes. It's not on either line, so try using 0, 0 and see what you can come up with. Where do these shaded regions overlap each other? I think you're going to end up with a figure that looks kind of like a distorted Pac-Man. All right, so I now know who the gamers are out there. Let's start with the circle. We'll test 0, 0 in there. 0 squared plus 0 squared is less than 9. That's true. So let me just kind of note for the record that I'm going to shade inside. And then let's work with the other region. I guess I can get rid of the timeout now too. Yeah. Let's try the other one. So I'll test 0, 0 again. This time I'm going to test it in this inequality. 2 times 0 plus 0 squared greater than or equal to 1. That one's false. 0 is not greater than 1. So am I going to shade inside or outside of the parabola? Outside. So that's going to be out here, out here, out here, out here. And if you carefully look at where these two shaded regions are going to overlap, they're going to overlap in here. So what you're left with is kind of this Pac-Man looking region. But they overlap in there. Okay. I think it's time to let you work on one kind of without a lot of guidance on this. Now, these first three that we've done, I've kind of helped you out by drawing the graphs, or at least drawing part of the graphs. So, I don't know. I'd like you to try problem number 34. 34 looks like this. I've got x minus y is greater than 0, and 4 plus y is less than or equal to 2x. Yeah, it should have been a plus. Yeah. So let's see. Do I still have sound? I still have sound. Yay. That's good. So excited.
True and not true. Though you had for this, you could test two. Don't do that. For this, you want to test one. You can't do that either. Oh, well, yeah, you can do one. I thought you were doing one.
Okay, so let's finish this up. So the big challenge, I think, for a lot of you was actually graphing the lines because they weren't there for you. So let's review that first. The first equation we want to graph comes from this one, and that turns into x minus y equals 0. And if you move the y to the side, you get x equals y. So x equals y is hopefully a graph that you're familiar with. You can certainly plot points to get that. There's a point at 0, 0, and points like 2 and 2, 4 and 4, etc. I'm going to draw this with a dashed line. Yeah, that dashed line, I mean, don't forget that because you'll get dinged for a point on that. Yes, dashed line versus a solid line. That's definitely a point of partial credit. You know, only one, but I want you to get all those points. Now, as far as the other inequality is concerned, we're going to start out by graphing 4 plus y equals 2x. You can just do this by plotting points. Set x equal to 0. So 4 plus y equals 2 times 0. Basically, 4 plus y equals 0. So y is negative 4. And on the other hand, if you set y equal to 0, we get 4 is 2x, so 2 for x. So those are a couple points, and I think that's going to be good enough to draw our graph, at least as long as you have confidence in your points and in your structure, both of which you do. Solid line or dashed line? Solid. Now it's a matter of testing points. You know, I think I want to pick a point that I can use twice. So let's pick this point right here at what? 0, 3. So 0, 3. Let's see what happens when we test those points. So I'll test 0, 3 in x minus y is greater than 0. So is 0 minus 3 greater than 0? True or false? False. So that lied above this line, so I need to shade below that line. So down here. Let's test our other one. Let's test 0, 3 again. This time we're going to test it in this inequality. So is 4 plus 3 less than or equal to 2 times 0? Did I get that right? 4 plus 3 is less than 2 times 0. So is 7 less than 0? False again. So this time, let's see, we're working with the green line, and it's telling me to shade below. And I didn't do a really good job of choosing the scale on this, did I? Where's our shaded region? It's just going to be that little piece right here, right? Up here. Isn't that where it? That's, what did I say, below? Oh, I'm sorry. All right, no, bigger region. This one down here, the big fat region down here. So yeah, below and below. My bad. All right, so let's do that in yellow. Right here. All right. So Jeff likes symmetry
Then you have to also shape the big region with the blue marker.
with the blue mark. I don't know.
That wasn't gonna be.
All right. So it's the yellow regions where both of these shaded regions overlap. I don't know. How about if we leave you with problems 40 and 56 to do at home because they're already kind of half done for you. And we'll just call it a day here. Wow, getting out early for homework. Let me give you a couple problems in addition to 40 and 56. Try 9 through 13, 21, 27 through 35, 39 through 49. And that's section 10.9. May sound like a lot, but I'll give you 5 days to work on it. See ya!
Have a nice day.
You too.